I love the color purple. It's my favorite. Or green.
What about blue?
Blues. Okay, some shades of blue are prettier than. What?
Is that a t-shirt dress?
Yeah. Uh-huh.
No, but my mom stole it for her spray cans.
For what?
Her spray cans. Because you can't like wear anything for a spray tan.
Why you just get tan?
Right? Thank
She doesn't understand.
you. Sorry, I don't spray tan or
No, I don't either.
fake tan or.
Listen, I can't tell you how many times in my life I've heard that.
I just go out in the sun.
That's what I tell her.
Good, yeah.
Yeah.
I actually tan really well in the summers.
I do too, but
It's still holding over just a little bit right there.
It is.
I see some.
super burnt in Maui. Like I was out for like way too long.
I mean, you gotta be smart about it.
Well, I didn't know such
Bianca.
melanoma all over my chest. I don't know if it's actually melanoma. I'm just very freckly on my chest now.
Alright, Jillian's gonna come do B for us. You should have that looked at.
That's what my mom just said. We'll get it done. Okay.
When you go for your regular checkup with your pediatrician, do you still go to a pediatrician?
I think so.
Yeah, you can go until you're 21. Have them look and they'll tell you if you need to go. They know how to check too.
Sorry.
No?
No, I will, because I don't want to get cancer.
Yeah, no.
Yeah, no more than
It's not really on my bucket list.
I don't think it's on anybody's bucket list.
I think it's on no one's bucket list.
Dang, that just looks like
Well,
filler.
'cause you're,
Sorry, guys.
You said you burned.
Yeah, I get, yeah. Because I'm in the sun like always, that's why.
Wear sunscreen.
Okay, I forget.
Sunscreen definitely like gives you
Do you want me to put the
Leslie, how are you against every
Should
single
I put
thing
the
in
fraction
the whole entire world?
Sure.
Doesn't the sunscreen have like harsh chemicals in it?
That's the
No.
aerosol one, and the
I guess
aerosol.
that's like you use. You gotta use like the kid friendly or something.
You're saying the UV radiation from the sun is
No, the
not
aerosol
worse.
ones have like harsh.
Lindsay's gonna come do C while you guys keep arguing about sunscreen.
Because the sun can also give you skin cancer.
It's not. It's about like the UV rate. It's not really about.
Oh
like,
my goodness.
You know what I'm saying?
She wants to
It's
smile
more
at me.
intense.
There's a lot to be said.
Shut up. Literally shut up.
Wesley, I think we should all just hide inside and never go outside because
Why are you so confidently wrong?
sun can.
He could be right. He could be
Because he's Wesley. Have you met him? No matter what comes out of his mouth, he's got confidence behind it.
English, like somebody was listening, he's like, no, I think that's too harsh. He's like, I think we're reaching. And it's like, it's up to your own interpretation.
That's why I hate English.
No.
English does suck. Like, I speak it great.
Poetry's a problem.
Yeah. Like,
No one likes poetry.
it
But
breaks
we're
all
going
those
to add
skills.
2 rules to it today. Alright. I do appreciate the sunscreen blah blah stuff. Sample space for tossing a coin 3 times. We did that together on Monday. So hopefully you were able to come up with that. Probability of getting 3 tails. There's only one way out of 8. So 0.125 or 12.5%. Wesley. B is getting more heads than tails. So more heads than tails happens when we get all heads. Tails, heads, 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 tails, heads, or heads, heads, tails. There's 4 ways to get more heads than tails. 4 out of 8, 50%, 0.5. So today we're going to learn 2 rules. So we are going to add to our rules a probability sheet. But before we get into those rules, we're going to define some things and look at some pictures. Because visuals are used a lot. All right, so we learned the complement rule on Monday. That tells us that the probability of a complement comes from 1 minus the probability of A. And I don't know what happened to my dashed line. Why did it stop so far over? We're just going to add to that. It's bugging me. There we go. All right, so simulations is a strategy to determine probabilities. Another strategy is to use visuals. One of the most common visuals we use is a Venn diagram. When we draw our Venn diagrams, we put them in boxes or rectangles. Those rectangles mean that we're looking at the entire sample space. So we label them with an S. The reason why we put the box, label it with an S, is because everything in this rectangle should add to 1 because it's our sample space, and probabilities, if it's a good probability model, will add to 1 when we add everything together. So our complement picture, we have the event A is going to be represented by that circle. That means the complement of A is everything in the rectangle but outside the circle. And because the rectangle is our sample space, everything in here adds to 1. So if I want to find the probability of a complement, I take 1 minus the probability of A, and that'll give me this value outside the circle. Today we're going to look at mutually exclusive events. How many of you have heard the term mutually exclusive? What does it mean? Yeah, can't do one and the other at the same time. Another word for mutually exclusive is disjoint. So if you see disjoint, again, you can't have them at the same time, so they can't be joined. So we have our rectangle, that's our sample space, and then we have event A. And then we have event B. There is no overlap because A cannot happen at the same time as B. That also means here we had A, which meant outside the circle was a complement. Outside these circles is what we would call A complement and B complement. A is not happening and B is not happening. Now we're going to look at a Venn diagram that shows us A and B happening at the same time. Just to, make life interesting, there is an alternate notation for the word and. It is like...
Isn't it that, like, funky U thing?
Yeah, it's an upside down U without the tail. It's an N, which I like that you called it an N because N is in the word and, so that tells you it's and.
So it's just A and B.
Mm-hmm. Yeah.
Yeah.
Yeah. So we have our sample space, our rectangle. This time we're interested in A and B. Said it like you. So there actually is an overlap when we draw our circles. So we have A And then we have B, and we have overlap. And that overlap, let's see, do it like this. Try to make it fit and be legible. A and B. That's that little area
Oh, shoot.
in the middle. Outside the two circles, A complement and B complement. A without the overlap, so almost like a crescent here. So that orange crescent that I just outlined with dashes, that can also be called B complement. A is happening in the pink circle. There's an overlap of the pink and the green. So if I take the pink circle minus the overlap part, that's B complement. B does not happen in that area. Same idea with B. If I take the crescent shape, so I get rid of the overlap from B, I could call that A complement. Yes.
It's like in the one in the top right, would A be B complement?
Yes, you could call that B complement. The outside is A complement and B complement. Neither of them are happening. If I was just interested in B complement, I'm going to use pencil to shade. It would be everything in the rectangle except for B. So yes, it would include A. Okay? So that shaded area is B complement only. The outside is the two together because neither happens outside the circles. A or B, again, keep it interesting. We have an alternate notation. This one is the one I call the U because it looks like U. The rectangle is our sample space. We have A and we have B. In the center where they overlap, that's A and B. A or B is the two circles and the overlap together. So everything in A plus the overlap plus everything in B. And then outside the two circles, A complement and B complement. Now, when we use Venn diagrams, we will have numbers so that hopefully it makes more sense. Biggest thing you need to remember is really there's 4 areas that we would label with numbers. Outside the circles within the rectangle, the A and B complement, that little crescent area, A and B, the overlap, and the B and A complement crescent area. So we should always have 4 numbers in there. I don't think we ever draw a Venn diagram that has 3 circles. I can't think of an example. We usually stick to 2 circles. Now we're going to actually define mutually exclusive. Caleb, what's your question?
When would we use A or B?
A or B? Well, we're going to do some A or B's in a minute. Like right here. A or B. That's going to be our rule today. We're going to learn about the addition rule for A or B, for mutually exclusive events, and for just in general. So after I do this example, maybe it'll answer your question. I'll come back to you, okay? All right, so like I said, first thing we're going to define in words mutually exclusive. DJ I can speak. DJ already told us mutually exclusive means we have 2 things that can't happen at once. So we have our 2 events, A and B. We say they're mutually exclusive, or remember, disjoint, if they have no outcome in common. And if they have no outcome in common, they can never occur together. If they can't occur together, then the probability of A and B happening, never occur, is 0. So our next probability rule, the addition rule for mutually exclusive events, we want to find the probability of A or B. So I told you A or B, when we have an overlap, is everything together. Same idea works up here, except for we don't have the overlap. So we would just say that we take the probability of A and add the probability of B so that we can find the probability of A or B happening. So an example problem for that, we're going to choose an American adult at random. We have 2 events. Event A is that the person has a cholesterol level of 240 milligrams per deciliter of blood or above, also known as high cholesterol. Event B, the person has a cholesterol level of 200 to 239 milligrams per deciliter of blood, also known as borderline high cholesterol. According to the American Heart Association, the probability of A is 0.16 and the probability of B is 0.29. Explain why events A and B are mutually exclusive. Why are A and B mutually exclusive? Seth?
You can't have at least 240 or more milligrams per deciliter of blood, as well as have between 200 and 239.
Perfect. So high cholesterol is defined as 240 or above. Borderline high means you're between 200 and 239. I cannot have a cholesterol level that is within both of those ranges. Just doesn't work by definition. So can't have high cholesterol. Which means 240 or above. Oops, I forgot my plus. Sorry. And borderline high, 200 to 239. at the same time. Any clarifying questions before we look at number 2? All right, say in plain language what the event A or B is. Anybody want to try? What does it mean to say A or B? What is A? Go ahead, Annika.
You have a cholesterol level of 240 or higher, which is high cholesterol, or 200 to 239, which is borderline high cholesterol.
Perfect. I'm going to abbreviate it a little because we also are going to find the probability, and my handwriting's too big. So I'm going to say event A or B means we excuse me, have either high or borderline high cholesterol. And then it is kind of hidden, but the other part of number 2 is to actually find the probability of A or B. We have our addition rule up here. Probability of A or B comes from the probability of A plus the probability of B. And at the very bottom of that paragraph, it told us, according to the American Heart Association, the probability of A is 0.16 and the probability of B is 0.29. So we're going to add those together, which would give us 3945.45. Any questions on that part before we move on to 3? All right, so we're going to introduce a third event, event C. We're going to say C is the event that the person chosen has normal cholesterol, meaning they are below 200 milligrams per deciliter of blood. What is the probability of C? What, Caleb? How'd you get that? 1 minus 45. So probability of C, normal cholesterol, sorry, that was a bad P, really is the same as the probability that A doesn't happen and B doesn't happen. So we're using the complement rule. And the probability that A doesn't happen and C doesn't happen, I'm going to zoom out so we can see our picture. A doesn't happen and B doesn't happen is everything outside our circles, so A or B. Same thing up here where A and B don't intersect. So it is using the complement rule. We can subtract from 1 like Caleb did. So we're going to do 1 minus the probability of A or B, which is 1 minus 0.45 or 0.55. Any questions? No? Can I flip? All right. We're going to work with a deck of cards. Did you have a question, Molly?
Oh, no.
Okay.
Sorry.
No, it's okay. Out of the corner of my eye, I saw your arm move,
Yeah, that was
and
just-
so I thought I'd check rather than assume. All right, so We're gonna pretend we shuffled a standard deck of playing cards. Standard infers that we're not using jokers, so jokers are removed. We talked about this yesterday, right? What's in a deck of cards? 52 cards, 4 suits, 13 of each suit. You have aces, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. Hearts and diamonds, those are reds. Clubs and spades are black. So we're going to work with a shuffled standard deck of playing cards, and we're going to deal 1 card. We have 2 events that we're going to focus on. Event J, which is getting a jack.
Wait, can I have a question?
Yeah.
Are we replacing?
We're only dealing 1 card, so no. It doesn't matter because we're only going to look at 1 card, nothing else. And then red, we use R, meaning we get a red card. Now, we could use a Venn diagram to create this, but another visual is to use a 2-way table, which we have worked with in the past, although it's been a while. It was in chapter 2 when we did marginal and conditional distributions. So we're going to remind ourselves how to work with 2-way tables. 2-way tables means we have a label across the top and a label going down the side. Doesn't matter which one's on the top or which one's on this side. I'm gonna put Jack or J on top. So there is event J, I get a Jack. And then there is J complement. I get a card that is not a Jack. And then the first thing that I had you guys do in chapter 2 with our 2-way tables was the total column. So we want to make sure, or the total row, so we want to make sure we include those as well. So I put my Jack, event J, and J complement on the top, so that means I'm going to put R, getting a red card, and R complement on the side. And then I need the total row as well.
Wouldn't you just say black instead of R complement because there's only one other?
Yeah, but it's also good to get in the habit of using complements rather than, I mean, you could say Jack, no Jack, red, not red, red, black, Jack. Not, I mean, there's lots of ways you could do it, but in probability when an event does not happen, we use complement, so it's just a good habit to do. Excuse me. All right, so now we're gonna fill this in. So, how many total cards? 52. So in the total, the very bottom corner here, we want to make sure we have 52. Of those 52 cards, how many are red? 26. Half the deck is red, half the deck is not red. How many jacks are in a deck of cards? 4. 1 for each suit, which means that we have 48 cards that are not jacks. Of our 4 jacks, how many of them are red?
2.
And that means 2 are not red. And then red jacks, we have 2 of them, which means red cards that are not jacks, there's 24. And then same thing for not red and not a jack, there are 24 of those cards as well. Any questions on those numbers before we move on? Now remember, with two-way tables in chapter 2, we would find the number in the middle and then we divide by the total. So when I want to find the probability of J, the probability I get a jack, there are 4 jacks total out of 52 cards. And we could use a calculator to get the decimal, but it's going to be a really hideous decimal, so are we good if we leave it as a fraction? And then we want to find the probability we get a red card. There are 26 out of the 52 cards that are red. That one is a better, simplifies down to 1/2, so 0.5. So we're going to now describe the event J and R in words. Said what R meant. What does it mean, J and R?
Jack.
What?
Both A and B.
I didn't use A and B.
Both J and R.
Both J and R.
What does J mean?
Jack.
What does R mean?
Red. Both Jack.
Red Jack.
A red jack. Just means a red jack. A red jack. So what's the probability of J and R that I get a red jack?
Just 50.
2 out of 52. Red and jack. There's only 2 red jacks. There are 52 cards total. What's the probability of J or R? The probability I get a jack or a red card.
30 out of 52.
Wesley says 30 out of 52. Anybody have a different answer? Sam? It would be 28 out of 52. Why is it 28 out of 52 and not 30 out of 52, Sam?
Because 2 of the jacks count as red cards.
Thank you, sir. These are not mutually exclusive events. We have red jacks. And Wesley did what I expected you guys to do. He said, oh, the probability of getting a jack is 4, red 26, so that'd be 30 out of 52. But this number right here, the 2 red jacks, gets counted in the 26 and the 4. So we have to take away a 2 so that we're not counting it twice, which is why 28 out of 52 is the correct answer. So when we have 2 events that are not mutually exclusive, like a red jack, the probability of finding A or B needs to be found differently than when we do mutually exclusive. So in mathematical terms, we would take the probability of A plus the probability of B, just like with mutually exclusive. But like Sam did, he said, oh, I counted that 2 twice. So we subtract the probability of A and B. So going back to D to show you how it works there. Probability of J, bless you, or R, using our new rule for any 2 events, we would take the probability of J plus the probability of R, and we would subtract the probability of J and R. We found the probability of J up here. It's 4 out of 52. probability of R was 26 out of 52, which is, like I said, where Wesley got the 30 out of 52. But then we have to subtract the probability of J and R, which we found in part C, is 2 out of 52. 4 plus 26 is 30, and 30 minus 2 is 28 out of 52. Questions? Took me forever to find the name. No questions? All right, we're going to look at another example. This one says in I can't do it. We have an apartment complex. 40% of the residents read the USA Today. 25% read the New York Times. 5% of residents read both papers. Suppose we select a resident of the apartment complex at random and record which of the two papers the person reads. So part A, we're going to construct a Venn diagram to represent the outcomes of our chance process. So first thing when we draw the Venn diagram is our rectangle to represent our sample space. Now I suppose before we go into drawing circles and stuff, it might help if we choose our letters. We can use A and B. I personally like to use letters that make sense with the actual things we're talking about. So I'm going to say let's use U for USA Today. And the other one is the New York Times. So I'm going to use N. Excuse me. So we have event U. Oops, I forgot to put my U. And then we have event N. Now, when you have numbers and you create a Venn diagram, you should always start with the overlap. So we're told that 5% read both. I'm going to change my percents to a decimal. So here in the middle for U and N, we have 0.05. Now the reason we start with the overlap is because we don't want to count that 5% when we put 40 for USA Today. USA Today is the pink circle, and that includes the 5% who read both. So what percent reads the USA Today but not the New York Times? 35. So we're going to put 0.35 here. And you might just want to make a little note, remind yourself that part of U is N complement, not reading the New York Times. Then 25% read the New York Times. That's our blue circle. We already have 5%, so what percent's over here? 20, thank you. So 0.2, and that's also U complement. And then the last part that we need to label is the stuff outside. So U complement and C complement, excuse me, N complement. I was thinking of the letter C for complement and said it. Sample space, remember, adds to 1. I have 0.35, 0.05, and 0.2. 0.35 plus 0.05 is 0.4. 0.4 plus 0.2 is 0.6. So that leaves 0.4 to be outside both circles. Like I said, you should have 4 numbers anytime you make a Venn diagram. Those 4 numbers should add to 1 if you made it correctly. Any questions? All right, part B, find the probability that the person reads at least one of the 2 papers. What does at least one mean? One or both. So the probability at least one is the same as asking for the probability that they read one of them or both of them. So that could mean that they read USA Today, but not the New York Times. They could read the New York Times or not USA Today, or they could read both. So it's all of that together, which if we go back to our picture is really the 2 circles, A or B. So one or both is the same as finding the probability of USA Today or New York Times. And we already did that to find the number out here was 0.35 plus 0.05 plus 0.2, which gave us 0.6. Part C, find the probability the person doesn't read either paper. Doesn't read USA Today, so you complement. And doesn't read the New York Times, so N complement, which we already labeled in our Venn diagram. It's everything outside the 2 circles, which is 0.4. Any questions? Bless you. No? Can I flip? Alright, you guys are going to try this one. I'm asking that you make a 2-way table and you make a Venn diagram. I'm going to be completely honest. Some kids, the 2-way table makes a heck of a lot more sense, and some kids, the Venn diagram makes sense. If you can make one of them, you can make the other. So just figure out which one clicks for you. So you have the information, read through it, try to make the 2-way table, try to make the Venn diagram, and then answer the questions down below, please. 60. Yeah, but you were counting the 5% twice. Because if you read both, that 5% is included in the USA Today, and then it's also included in the New York Times. Must be nice to be rich.
I know, right?
Anyway.
Did that clarify?
It's just
You gotta do this.
Hey. She totally looked at me when I was sweeping up the cans. And then when I said, hey, to her, she like rolled her eyes at me. I saw it.
For me?
Yeah.
Oh. I blame it on my mom. She used to roll her eyes all the time with her teachers, so teacher would be like, stop rolling your eyes. She'd be like, oh, okay. And rolls her eyes out, so that's okay. And I'm like, you did great. She's like, oh. Like, it's just so big. Yeah, you're like, this is what I do. You, yeah. You raised me.
you made me. So.
That's one of those things where you're like, no, you definitely gotta figure that. You definitely gotta.
Open that one to do it for my dad.
These are definitely even circles.
Oh,
They like to
It's
block
like
the
a
bottom.
Dude, I made one under the egg. I was like,
Yeah.
that's what you want to be.
Oh.
Alright, I know some of you are still working, but I'm going to have Caleb start the Venn diagram, or two-way table, excuse me, two-way table for us.
It's right so far. Or wrong.
Your Venn diagram?
No. I'm not confused how to, like, what do I add into
T and C complement, so T and C complement are 18.
Oh, okay. So I was like, I think diagram makes sense to my brain. This one, I'm like,
I told you guys, some kids it's really interesting
Yeah.
to see which kids like the Venn diagram and which kids are like, oh, the two-way table, that makes a heck of a lot more sense. So I'm going to have you do the Venn diagram in a minute. Reason. Thank you, Caleb. Alright, Emma is going to put up our Venn diagram.
thank you.
I'm going to have you do C,
Yeah. That's great.
Spain or Australia?
Spade.
You think Spain's gonna win?
Oh yeah. Not the best team.
They look so funny running. So funny.
Ooh.
The players from this angle, they look like little tiny, like ants.
So see right here.
Sorry, it shows you.
See right here.
Oh, true. That's so much work.
It's
The biggest thing I would ask is grammar and
right. That's what it is. Nice. Oh wait, oh wait, what's the top part? Oh, it's like what's left on the outside. Yeah. Okay. Wait. It's like if you added up one letters. Oh, like we used T and C. I used L and C.
I used L and C. Those were my letters.
L and C?
Landline, cell phone.
Yeah, I put 2 letters.
You just translate that.
Seth, will you do D, please? DJ wrote probability of at least 1 is equal to the probability of 1 or both, which really is equal to the probability of P or C, which is 0.98. I'm going to connect the top of your 9 because it looks like 4. Sorry, DJ. 0.98, so 98%. And then Seth is doing D for us. Excuse me. Germany score.
Are you scored?
Yep. Ooh, it was pretty too.
It's when they have big name buns. Wouldn't that be annoying when you play?
Well, I'm a lady and I'm used to having buns.
So for us, if you see your normal.
A or B equals S, does that mean A or B have to equal 1? Which means there's no chance of nothing happening.
All right, a lot of you have started working on the challenge problem.
Oh, no, go back on.
Oh, I'm sorry.
I just need to be able to CC.
Try the challenge problem though. I do want you to try it on your own. If I find somebody who gets it, I might have them come to the board. But I want you to try this one first on your own before I just tell you.
That guy got? Like last year?
They
You
just
got so
scored in the
much
first.
hate.
That was such a
Germany's
that was
already
a
ahead
dirty
too.
goal. That was
didn't
a
This was the
dirty
death
goal.
group. Spain and Germany.
Oh my
Like whoever
god.
else is in that.
That was
This
disgusting.
is the death
That goal was disgusting.
Hold on, let me see.
group.
What was that?
They gotta do the little infinity sign. They go.
He did this.
Okay.
What, sucks his thumb?
What is that? He did it.
Baby.
I don't know. Maybe.
He's calling you a
Look,
baby.
look.
Okay.
It's kind of anticlimactic.
How is that dirty?
That's all I'm
Just
saying.
you didn't like it?
Just in the moment. In the moment, I felt really.
You know what, remember how much hate he got? Did you know about that?
Why do the goals seem smaller?
Because the goalie's huge, probably.
Yeah, that is true.
This
They
guy's
are
part of
some
that big.
huge dudes.
Oh, look at that.
Bummer.
Oh, it hit
Like,
the
you know,
camera.
Kurta, the Belgian keeper, he blocks like the whole goal.
Oh, well. See, I came over here to watch it. That's because of me. That goal was because of me.
Oh,
I'm just saying.
I'm not gonna lie, like, literally right when you said
I
the ball
literally,
scored.
right when I came over
did
here,
score.
they did score. Is this on Peacock?
Come on, who's got the point?
Yeah.
See, you should do the challenge.
Oh, she's recording. Oh,
The challenge was me doing.
she's recording.
You can hear her whole thing?
I guess.
That's goofy.
I was looking at the roster and some of the Spain players are kind of hot.
Yeah? Like who? You like Ferran Torres?
The Spain and Japan game.
You like Ferran
Oh,
Torres?
hell nah.
Oh, hell nah.
Bianca,
What?
Spain.
What about Spain?
You think Ferran Torres is
Wait,
hot or what?
it's
One
ow.
of them. I forgot which one. Oh, that's
I think Asensio's hot.
Who?
Asensio? That guy?
I don't know. I just kind of looked at the
Like
roster
Morata?
and I was like, shut up.
Oh, you mean
I'm trying this one.
I'm proud of you, Emma.
Oh, you talk about Gabby probably.
No.
He's our age.
That wasn't your phone. No, I can see.
My phone don't really work.
Why not?
I don't have data right now.
How do you not have data?
I ran out somehow. I'm not even using my phone.
Don't make them score.
Oh, they scored.
don't we already know that?
They're on the other side of the field.
So you gave us the answer.
Yeah, no, it was like a 10% chance of Japan winning.
Yeah.
So depressing.
Spain's probably like the second best team.
Who do you think will make it to the final?
Brazil, definitely.
Brazil and France.
I don't like France, so I hope.
Well, I mean, they're good though.
Yeah, I don't think they'll go all
Yeah,
the
look,
way.
a 4% chance at winning. That's so depressing.
Well, that's now because they scored. So.
Hey, they've had one shot on goal.
When you watch the Japanese games, they look so pretty.
I'll be right there.
This guy. This guy.
Blade?
This is not Blade.
Bianca,
This
go
is,
try the challenge
this is
problem.
Bald. His
It
name
says
is
Blade.
Bald. It's not. That's not Blade.
Bianca, challenge problem.
Oh, Blade.
Balib.
Oh, wait.
I swear I let my wife keep
Yeah.
Oh, this guy too, Torres.
I told you that. Oh, you like that one? The Cowboys?
Look around.
Huh?
No, they're not.
You like Cowboys?
I'm gonna look at this picture.
He's interested.
Wait, are you sure they
Yeah, let's talk about the other one. The other Torres.
I'm like,
Did you not start this game?
No.
okay.
Okay.
He's like, no, they're definitely not at my house.
No.
I don't know where you left them. I feel like they're hanging. I was like, I swear I brought those to your house. When I go swimming, they were there.
It's like.
Oh, so it's 4 Venn diagrams? That Venn? Make a table for the Venn diagram.
Oh wait, no, it is.
That's a lot of math, to be honest. I know she has pretty nice circles. You like
So
took
this
the
one messed
time.
up, but this one.
Hey, Ray?
There's no space between the A and the
She's got her
Oh,
little.
okay,
She's
right,
like,
yeah. Oh yeah, the little.
yeah.
Wait, okay. This is what. What it says.
She can do the circle thing.
A.
Oh my god.
I can't do it right now. My shoulder's hurt.
Is A and B complex and so it's adding or it's like this one?
Just that one.
Okay.
You would just like have to start.
A and B, C equal 129.
Ow.
Let's do the diagram. Figure it out as I go. Oh my gosh, it looks like an egg.
What?
Now it's going what's
Oh, it's so skinny.
It's just not happening.
Oh, we.
Because you're up with a Venn diagram.
Yeah.
And so we put
Oh,
Venn
that was
diagram,
a
at least
little
for me, is harder than this.
Yeah.
Because like the Venn diagram would be like a rectangle without the circle.
But at the same
I'm
time,
not even. Was it a do? I'm assuming it's Mr. Van. Just know that it's a balanced strategy for probability.
Just you wouldn't think just didn't like because like I don't know. If you use circles, there's going to be open space. But
So you can also
Okay,
just probably give it
this
space
is
saying
correct.
there's
Put your answer.
yeah,
which is what I did.
Wait a second.
What's the probability of being?
but like that.
That's why you mark your thing.
Oh, it's saying the outside is 129.
I won't listen to you. Listen.
You just
But I'm the one that figured it out. He figured out the whole sample space.
I already know.
Can't do this last problem. You did it?
This chalk problem is
Truly.
Alright, Sam is gonna make a two-way table. That's how he approached it.
The wrong way.
No. Like
I'm
I
so
said,
sorry. I tried my best.
You can make a two-way table, you can make a Venn diagram. So either way is good.
Wait, okay.
Already so much
I was gonna be like, well, there's some TV. Just
Say that again?
I don't think you realize how much I just blocked you.
How do you get this? Because no one remembers. Oh, I see. Because you would be able to draw your Venn diagram.
It's also because all the other ones
Do you want to explain?
No.
Aw, man. Come on, Sam. All right, the key is the very first part. A or B is your sample space. That means A or B equals 1. So if we flip back, A or B equaling 1 means that this area outside the circles is 0. So A complement and B complement, A not happening, B not happening, has to be 0. And that's the key that allows you to find all the other values. We know A happening and B not happening is 0.25, so that's right here. A not happening, which is B happening, 0.35. We have 0 here, which allows us to find some totals. And we know that it's equal to 1, so this has to be 0.75, which means the overlap is 0.4. The question was, what's the probability of B? That would be the total for B, or if you drew the Venn diagrams. Let's see if I can draw them really quick. Here's A, here's B, A, B, B complement, A complement, A and B, A complement and B complement. Sorry, that was a weird. We know A and B complement 0.25. The first thing that I highlighted tells us this area out here is 0. B and A complement is 0.35. And we know that these three numbers have to add to 1 because the outside is 0. 0.25 plus 0.35 is 0.6, which leaves 0.4 in the middle. So the probability of B would be this whole area here, or 0.4 and 0.35, which is how we get 0.75. Excuse me. Thank you. I did run out of time, but you do have 2 new rules to add to your rules of probability sheet.
Is it just what we already filled out?
The 2 rules, I put rule number 2 right there, and then rule number 3 is right here. So you can add them to your rule sheet. The word rule sounds weird when you say it multiple times. Rule, rule. Is your name on it?
You ever grade that project thing?
Not yet.
Well, do I need to retake the test?
I will write it for you.
I don't know if I need to retake the test though. Here, I'm gonna come in for lunch tomorrow then probably, okay?
Okay.
And then we can look over my test.
Okay.
And I'll retake it.